Combustion of fuel is an ancient way to generate heat and power. Today, efficient combustion of biomass and waste is a key component in our sustainable society. The task of a steam boiler is to transform the stored energy in the fuel to high-pressure steam as efficiently as possible. The high-pressure steam is then expanded in the power plant turbine, generating electrical energy. To maximize the electrical output, as much steam as possible should be generated from the fuel, and the steam should also be as hot as the material in the boiler and the turbine can handle. The steam temperature is important, since the efficiency of the turbine increases with increasing steam temperature. One problem with combustion is the resulting ash in the flue gas, which causes fouling and slagging on the surfaces on the fire side of the boiler. The fouling inhibits the important heat exchange from the hot flue gases to the steam, which is used for power generation. Clean surfaces give high steam temperatures and high steam production. As the fouling increases, steam production and the important steam temperature drops. To restore the heat exchange, the surfaces are cleaned with high-pressure steam. This steam soot blowing is performed regularly, normally between 2 to 3 times per day. The fouling causes losses, depending on fouling rate and the intervals between steam soot blowing. Soot blowing is normally performed 2 to 3 times per day at full boiler operation. The graph illustrates a real example of how fouling and soot blowing affect the steam temperature. A sawtooth pattern is clearly seen where the temperature drops and gets restored during soot blowing. The energy losses from the fouling directly affect the heat and power production. The energy losses from ash buildup in this case account for 1.5% of the total production. So why not soot blow more often? It seems like an easy way to increase the efficiency. The answer is simple. Soot blowing costs money, and it costs for many reasons. The cost of steam. Soot blowing consumes high-pressure steam, which could have been used for power generation. Boiler wear. During soot blowing, hard ash particles and condensate are pulled into the steam jet, blasting the heating surfaces. Production losses. Most commonly, the boiler load must be decreased during the soot blowing cycle. Efficiency losses. Steam regulation must be locked during soot blowing. Disruption of the boiler flue gas cleaning and subsequent load regulations. Soot blowing is not cheap, so we do not want to spend more time and steam on soot blowing more than necessary. Is there any way of soot blowing more without spending more time and steam? Given what we have learned, it sounds impossible. But heat management has developed a patented technology, making it possible to increase the soot blowing without taking longer time, consuming more steam, or wearing out the boiler surfaces. The technology is based on the physics of steam soot blowing. Steam soot blowing is normally performed with rotating lances, cleaning the boiler heating surfaces with high-pressure steam. Cleaning is performed when the lance moves into the boiler and when it moves out. A known fact is that nearly 100% of the cleaning occurs on the first pass of the steam jet, and almost no cleaning is achieved on the return. Classical steam soot blowing therefore means that half the steam, half the wear, half the disruption time, and half of the production loss is of virtually no use. Heat management has developed a patented technology called HISS soot blowing, where HISS stands for High Impact Soot System. HISS soot blowing is based on the potential that half of the cost and issues related with soot blowing are unnecessary. HISS soot blowing is a refined version of one-way soot blowing. The soot blower steam poppet valve is controlled so that steam flow only occurs in one direction and is coupled with a patented control system where the soot blowers are operated overlapping, forward and reverse. HISS soot blowing effectively halves the steam and time spent on soot blowing, at half the wear of the boiler surfaces. HISS overlapping soot blowing turns the economy of fouling prevention on its head, where shortening the soot blowing time and steam consumption makes the impossible possible, to increase the soot blowing while decreasing the cost. Consider a conventional 40 megawatt biomass-fired steam boiler, which uses classical soot blowing 3 times per day and decreases the boiler load by 10% during the soot blowing cycle. With his soot blowing, it would be natural to increase the electrical efficiency by cleaning the hanging superheaters twice as often as today, and probably the backpass superheater 4 times per day instead of 3. The rest of the boiler, including the economizer and air preheater, is cleaned as often as before. Soot blowing this way means approximately 47% more soot blowing in total, while consuming 27% less steam and wearing the boiler out at a 27% lower rate, during a 27% shorter disturbance time. The result is an increased overall efficiency of the heat and power generation, allowing for an additional daily yield of 9 megawatt-hours electricity and 13 megawatt-hours of heat from the same amount of fuel. On an annual basis, the steam savings amount to 1,100 tons, and reduced production losses is 4,800 megawatt-hours. The sintering rate and plugging risk are reduced, together with the soot blowing induced wear on the boiler. Heat management offers complete installation projects for rebuilding to his soot blowing. We deliver equipment and validated control software for safe overlapping one-way steam soot blowing. As a first step, we recommend a diagnostic pre-study that maps the thermodynamic potential for the soot blowing of your specific boiler. Step into the world of modern soot blowing. One way, the smart way, heat management.